So first example today is just a review of yesterday. So remember, we solved by graphing. We're hunting for the point where these lines are going to intersect because that's going to be the ordered pair that makes both of these two equations true. You want to get your lines into y-intercept form. So, the y's over here on the right. Let's move it back to the left, which makes it positive y, which means if I move the 3x to the right, it'll be negative 3x. If I move the 1 to the right, it'll be negative 1. This one, y is on the left. Move the x, push the 7, divide both sides by negative 1. It's just going to change all the signs. Okay, so y-intercept of the first one's at negative 1, and then you go down 3, right 1, up 3, back 1. Got that one. So remember, that line represents all the ordered pairs that make this a true statement. Y equals x plus 7, so we got a y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. And then rise 1, run 1. I'm running away from the other lines. Let's go the other direction. There's where they intersect. It's at back 2, 1, 2, 3, 4, up 5. So the solution to that system is at negative 2, 5. If I want to double check, make sure I'm correct. Let's come back. Excuse me. Is 3 times the x in my ordered pair added to 1 the same thing as the opposite of that y? Negative 6 plus 1 does equal negative 5. Is the x minus the y equal to negative 7? Sure is. I know it's right. Okay. But what if you have this one? Like the second line, that's not a big deal. Y-intercept is negative 10. Go down 3, right 1, I'm off the page. Go up 3, back 1. I'm not. I can sit and draw this line. But this one, divide both sides by that negative 5. That part's not 3/5 x. That's no big deal. Negative and negative is positive. 3 into this goes 62 times. Yeah, that won't fit on the screen. I'd have to change my scale, or else I have a really big sheet of graph paper if I'm going to graph that. Now, does it mean that those lines won't cross? Of course it doesn't. Those lines definitely cross. There's going to be a point of intersection, but sometimes solving by graphing maybe not the best way to figure out an answer. So we can come up with an alternative. And the one we're going to do today is solving these linear equations by something called substitution. And it's exactly like it sounds. We're just going to substitute a value in the place of another value. Okay? So let's learn how to do it. Here's our two equations. If we were going to graph them, yeah, we could. But you'd have a y-intercept of 19/5 on this second equation. Nobody wants to deal with that. You're not even going to be able to tell where they cross probably by eyeballing it. So here's the way we were going to do this. Now, if you want steps, there they are. Okay, I'm not real big on teaching steps. I think that kind of takes the understanding out of it. What we need to do is have an equation that only has one variable in it, because we know how to solve those. The top one has an x and y. The bottom one has an x and y. That's not helpful for us. However, this thing says that y equals this right here. That's the same thing as y. So if I take that second equation, and where there's a y right there, I put in negative 2x minus 9. Well, that is what y is. If I replace a 2 plus 3 with a 5, I just did substitution. I replaced an expression with a value that's equal to it. That's what I want to do. But now my advantage is that everything in here is an x. Now, if you struggled solving for x back in chapter 1, you're going to struggle here. You're going to have to work harder. That's all there's to it. I can't give you a magic bullet to get out of this. You've got to be able to solve for x. So I'm going to distribute that negative 5. Negative 5 times negative 2x is positive 10x. Negative 5 times negative 9 is positive 45. Over here on the left-hand side, there are two like terms. I'm going to put those together. Oops. I want the x's on one side. I want the numbers on the other. So I'm going to move that negative 45, the 45 to the other side, which makes it negative 45, because I am subtracting 45 from both sides. And that'll get me for negative 64. If I divide both sides by 16, I'm going to get that x is negative 4. Okay, but remember, the solution to a system is an ordered pair. All we just got was the x. So now I'm going to go figure out the y. And you can plug it in either of these two equations that you want. I'm going to plug it in the top one because to me that looks easier. It says if I take negative 2 and multiply by x and subtract 9, I will get what y is. So y is negative 17. And then I've got my answer. Now, again, we can still check our answers. If I take and say, okay, is the y, negative 17, is it the same as negative 2 times the, oops, no, they're too close to the top. Let me write. Negative 2 times the x minus 9. That's 8. Uh-oh. That's 8 minus 9. That's negative 1. That is not the same. There you go. What did I just do? Plus 45. Negative 5. 6x plus 10x plus 45. X is negative 4. Oh, there it is. Oh my gosh. I'm going to pretend like I didn't just have a ridiculous thing happen. I'm going to pretend like I did this on purpose, but you obviously know I didn't. Look at this. I said that negative 2 times negative 4 was negative 8. Yeah, that's a positive 8. How about we put what it actually is? How about we put negative 1? But the reason I'm saying I could pretend is because, hey, look, the fact that I sat here and checked it let me catch my mistake. And that's a good thing. So if y is negative 1, there we go. So that is true. If I plug it into this one, 6 times the x minus 5 times the y, does that equal negative 19? It sure does. And I know I'm good. Okay. All right. So this one, again, this is what y is. So let's plug it in where y goes. So negative 4x is 3x plus 14. Let's say we get the x's on one side, constants on the other. If I divide both sides by negative 7, I'm going to get negative 2. Pick one of these two equations. Your y is negative 4 times your x. So your y is 8. There's our solution. And again, if we double check, is the y 3 times the x plus 14? It sure is. Is your y negative 4 times your x? It sure is. Okay. All right, right here. Here's what x is. Let's plug it where x is. Distribute the 4. $24y plus y is 25y's. So if I get my y's on one side, constants on the other, divide both sides by 25, y's got to be 1. X is 6 times y minus 7. So x is negative 1. Okay, again, let's check. Is my x 6 times the y minus 7. It is. Is 4 times my x plus my y equal to -3? It is. Okay. All right, this one's got a fraction in it. Don't worry. Here's y. Plug it in where y goes. Distribute the 2. Half of 2 is 1. That one's got x on it. Minus 2. Right there's 4 x's. I'm going to move the 2 to the other side. Now when I divide both sides by 4, x will be a half, which is okay. Okay. Y is 1/2 times x minus 1 more. Okay, remember 1 over 1, that's the thing, is 4 over 4. There's y, 1/2, -3/4. Sometimes they're fraction answers. We're not going to do that too much while you're learning how, but I just want you to see one where it's like, oh, it can be a fraction. And if we checked it, we'll do it in a different color. Top one, 3 times x plus 2 times y is at 0. So this is 3/2. Here's 2 goes in that twice, minus 3/2. It sure is. And then is the y. I'm checking the bottom one now. Equal to half of the x minus 1. It sure is. Okay. All right, this one. There's y. Plug it right there. And this is the one we started out the lesson with. Distribute. Distribute. Here's 18x plus 50. And the numbers over here. Divide both sides by 18. Let's see, that'd be negative 180 over 9. That's what, negative 20? And then my y is -3 times my x minus 10. So my y is 50. So there's my ordered pair. That's the solution of the system. Again, let's check it. Checking the first equation right there. 3 times my x minus 5 times my y, is that -310? It is. Is my y, this is checking the second one, equal to -3 times my x minus 10? It is. I know it's right.